Hey folks, so it's become clear we need to do some work on our fractions, and that's the purpose of this UYAS. So we'll be doing stuff like adding, subtracting, multiplying, and dividing fractions, as well as converting between mixed numbers and improper fractions. So we're going to actually start with the conversion between mixed numbers and improper fractions, because that's something that's going to be very important to us as we look at adding, subtracting, multiplying, and dividing. So here we go. So let's consider the number 5 and 2/7. Now remember, this means 5 whole numbers and then 2/7 of another unit. So we can look at this and we can say, okay, well this 5 right here, this is really 35/7, and I know that I've got 2/7 in addition to that. I add those two together and I get 37/7. Now some people try to remember something like, multiply this times this and add that to this and keep it over 7. And you try to remember something like that, it does work, but I think you'll find yourself on much surer footing if you remember what's this whole number equal to in terms of 7ths, and then add my 2/7 to that. Alright, now let's look at -4 and 1/5. Now remember that this is -4 and a -1/5, right? So it's a little bit more negative than -4. We're going to do a similar process where we look at this and we say, okay, -4 is really -20/5, and then we've got another -1/5 on top of that, which makes it -21/5. Now, if the business with this 1/5 being negative is problematic for you, one thing you can do is sort of take away the negative while you're working on it and say, okay, 4 and 1/5 is going to be equal to 21/5. And then say, okay, if it were -4 and 1/5, it would be -21/5, and deal with the negative at the end there. Now the other part of this is, what if we have an improper fraction? How do we get that to a mixed number? So let's look at a number like 42/13. Now I have to remember, this really means 42 divided by 13. So, if we want, with larger numbers, it really makes sense to set this up. But even here, it makes sense to set up some long division. We look at this and say, okay, 13 goes into 42 3 times. 3 times 13 is 39, which when I subtract is going to give me 3. So this is 3 with a remainder of 3. So what this means is that 42/13 is, well, 3, and then I've got this remainder of 3 that still needs to be divided by the 13. So maybe this wasn't the best example since both numbers are 3's, but this one right here is telling me that when I divide I get 3 whole numbers. And this remainder right here is telling me that that 3 still needs to get divided by the 13 in the end. Now let's look at one that's a little bit more painful. We'll actually need to do the division again. And this time I'm going to do what I talked about in the first example. Is this negative sign right here? I'm going to ignore it for the time being and come back to that in the end. So I'll do my long division. 521 divided by 7. 7 doesn't go into 5, but it goes into 52 7 times. 7 times 7 is 49. I subtract, I get 3, 1. 7 goes into 31 4 times, and 7 times 4 is 28, so that gives me a remainder of 3. So what this means, well, 521/7 would be 74 and 3/7, but then I need to remember that, oops, I've got that negative there, so this is -74 and 3/7. So now with that under our belts, we're going to move on to adding, subtracting, multiplying, and dividing our fractions. So as many of you probably remember, multiplying fractions is fairly straightforward. It's probably one of the easier operations we can do with fractions. If I've got something like 2/3 times, say 4/7, I just multiply right across and I'll get 8/21. So that's pretty straightforward. Things get more difficult though when I add little complications like having mixed numbers. It turns out improper fractions pose no problem for us. So for example, 16/7 times 3/4, this is going to pose no problem for us. But there's a little bit more we can do here. I could multiply straight across, and I would get this is 48/28. But you all know I'm not going to accept that for an answer. And I need to clean this up so it looks like an 8. You know I'm not going to accept that as an answer. You know that needs to be reduced. Now there's a way that we can reduce earlier on. We can reduce right here by looking and saying, oh look, this 16 and this 4, they have something in common, so I can really cross-cancel here, get a 4 and a 1, so that would be really 12/7, which is exactly what I'm going to get if I reduce this fraction here. So you don't absolutely have to do this cross-canceling here like I did to pre-reduce my fraction, but you're going to have to reduce sooner or later, and I find this to be much easier and save a lot of computation time. But you can come here and reduce here. Now the question is, what do I do if I get something like -2/7 times 3 2/3? Well, this is no longer so easy. It was easy when I had two fractions that were written as just one number divided by another. So what we actually need to do to start with here is turn this into an improper fraction. So we'll notice that this is actually 11/3. So we'll rewrite the problem as -2/7 times 11/3, and then I can multiply and get -22/21. So in general, I would bear in mind that in terms of computation, improper fractions are almost always easier to work with than mixed numbers. So dividing fractions is pretty similar to multiplying. Let's say we were dealing with 4/9 divided by, let's say 1/3. Now, remember that dividing, as we sort of worked on in Chapter 1, is really multiplying by the multiplicative inverse. So that's why you probably remember the old rule that we take 4/9 and we're going to multiply it by the multiplicative inverse of 1/3, which is 3/1. So I'm not going to quiz you on why this works, but that is why it's working. In essence, we just need to take that second fraction, flip it, and multiply. And again, I'm going to pre-reduce here and say, okay, there's 1, there's 3, and that's going to give me my final answer of 4/3. And again, when given mixed numbers, I will want to convert them to improper fractions. So if I have -2 1/5 divided by -3 4/7, I'm going to change this problem into, okay, that's -11/5 divided by -25/7. And now I can go ahead and flip my second fraction, so I get -11/5 times -7/25, and that's going to get me a positive 77/125. And you'll notice in this case there was no pre-reducing to do. 11 and 25 have no factors in common, 7 and 5 have no factors in common, so we've got no pre-reducing we can do, which means there's no reducing we can do here, and this is our final answer. So adding and subtracting fractions is the final topic that we need to deal with. Now, as you probably remember, when we've got a common denominator, no big deal. I've got 2/7 plus 1/7, that's going to give me 3/7. Kind of like if I've got 2x plus x, I get 3x. Or if I've got 2 square roots of 2 plus the square root of 2, I get 3 square roots of 2. Similar idea there. Subtracting would be the same idea, except now I've got this problem that I don't have the same denominator. So what I'm going to look for is I'm going to look for the least common denominator between these two. And it will always work to just multiply this one on the left by 7/7, this one on the right by 8/8. In some cases you will have smaller numbers you can multiply by, but this will always work. So that's going to get us, then we're going to have 21/56 minus 32/56. And when we actually do that subtraction, we're going to find that we get -11/56. Now at this point I need to check and make sure it can't be reduced, but since the top is prime and 56 is not divisible by 11, I'm in good shape. Now again, mixed numbers are a pain in the butt. Let's say I've got 3 2/5 plus 1 5/6. So I'm going to rewrite this as, okay, this is going to be 17/5 plus 11/6. Right, and then I'll multiply here by 6/6, here by 5/5. And what am I going to get? I'm going to get 102/30ths plus 55/30ths. And I add and I get, okay, that's going to be 157 thirtieths. And a quick check reveals that 30 is divisible by 2, 3, and 5. The numerator is divisible by none of these. So that's my final answer, since this can't be reduced, is 157 thirtieths.